Hey everyone, and welcome to another deep dive. Today we're blasting off to explore something that sounds straight out of science fiction, but is rapidly becoming a reality. Asteroid mining.
It's a fascinating field, isn't it?
Absolutely. And to help us navigate this exciting frontier, we're diving into an academic chapter titled Introduction to Asteroid Mining as a Technological Frontier.
A great choice. It lays out the fundamentals really well.
It really does. And trust me, listeners, this is some seriously mind-blowing stuff. We're talking about asteroids that could contain more platinum than we've ever mined here on Earth.
It's incredible to think about, right? A single asteroid holding more resources than we've extracted in our entire history. And it's not just precious metals either.
Exactly. We're talking everything from water, which is essential for, well, everything in space,
Life support, propulsion, you name it.
to those platinum group metals, which are crucial for all sorts of advanced tech right here on Earth. So before we get ahead of ourselves, let's start with the basics. What exactly is asteroid mining?
Well, at its most basic, it's exactly what it sounds like. Extracting valuable resources from asteroids. Imagine robotic miners out there, drilling, cutting, processing materials on these celestial bodies.
Okay, so when I hear mining, I picture like massive earth-moving equipment. How does that even work in the environment of space?
Ah, that's where things get really interesting. We're talking about zero gravity, extreme temperatures, radiation.
Right, those are some serious obstacles to overcome. Where do you even begin?
You have to completely rethink conventional mining. Let's take microgravity, for example. Trying to drill into an asteroid when you have no weight. Forget about it. Instead of the drill bit biting into the rock, the force could just send you spinning wildly out of control.
Oh, wow, I hadn't even thought about that. Makes sense, though.
Yeah, so engineers are developing some really clever solutions. The things like electromagnetic anchors, which clamp onto the asteroid using magnetic fields, providing a stable platform.
So using magnets to hold yourself in place, that's pretty ingenious.
It is. There are other ideas too, like tethers to secure equipment, even harnessing the asteroid's rotation to generate artificial gravity.
Wow, it seems like we're going to need some serious innovation to make all this work.
Definitely. And microgravity is just one challenge. The vacuum of space also presents its own set of hurdles.
How so?
Well, materials behave very differently in a vacuum compared to Earth. Some can outgas, releasing trapped gases. Others become brittle and fracture. It means we need specialized space-grade materials for everything, from the mining equipment to habitats.
So we can't just take our Earth-based tech and expect it to work up there.
Nope. And then, of course, there's radiation.
Right, that's a big one. Dangerous for equipment and humans alike.
Exactly. We need shielding for spacecraft and habitats, and will likely rely heavily on robots and autonomous systems to minimize the risk to humans.
Makes sense. So sending robotic miners out to do the heavy lifting, controlled remotely from a safe distance, that's starting to paint a clearer picture. Now, I'm curious, how did we even come up with this audacious idea of mining asteroids in the first place? It's not exactly something you brainstorm over coffee, is it?
Haha, you're right about that. But the idea has actually been around for quite a while. Visionaries like Gerard K. O'Neill back in the 1970s proposed using off-Earth resources to build space habitats.
So it started as a theoretical concept, but it's quickly becoming reality. What are some of the milestones that have brought us to this point?
Well, we've seen some major progress in both scientific exploration and technological development. Missions like OSIRIS-REx and Hayabusa 2 have successfully returned samples from asteroids, giving us incredible insights into their composition and potential.
That's right, they actually brought back pieces of asteroids. This isn't just theory anymore.
Absolutely. And it's not just governments driving this either. Private companies like Planetary Resources and deep space industries have been making significant investments.
So the private sector is seeing the potential here too.
Big time. It's not just a scientific endeavor anymore, it's becoming a commercial one as well. And speaking of potential, it's important to remember that not all asteroids are created equal.
Right, just like in the gold rush, you had to know what you were looking for. So let's talk about the different types of asteroids and what treasures each one holds.
Absolutely. There are three main types that are of particular interest. We have the C-type asteroids, rich in water and organic compounds.
So these are the ones that could be our cosmic gas stations.
Exactly. The chapter even specifically mentions Bennu and Ryugu as examples, which is cool because we've already sent missions to them.
That's right. Okay, what about the other types?
Well, then we have the S-types, abundant in metals like nickel and iron, essential for construction and manufacturing. 433 Eros is a good example of an S-type.
Okay, so C-types for fuel and life support, S-types for building materials. What's the third type?
The M types. These are the real heavy hitters when it comes to valuable metals. Metallic, with high concentrations of things like platinum and iridium.
So the ones everyone's going to be after. Any specific examples of an M-type?
16 Psyche. It's thought to be the exposed metallic core of a protoplanet, and it's gotten a lot of attention.
Wow, a whole asteroid made of metal. That's incredible. Okay, so we've got our asteroid types and the riches they hold. But let's get back to the practicalities. We've talked about the challenges of working in space, but how do we even find the right asteroids in the vastness of our solar system? It's like finding a needle in a cosmic haystack.
That's where detection and classification come in. We use all sorts of techniques, from ground-based telescopes to space-based observatories to even radar, to scan the skies for potential targets.
So it's a bit of a cosmic treasure hunt, using high-tech tools to pinpoint the most promising asteroids.
Exactly. We analyze the light reflected from them, which gives us clues about their composition, whether they might hold the resources we're after.
It's like a fingerprint telling us what the asteroid is made of. That's fascinating. So once we've identified a potential target, what happens next? Do we just launch a mission and start digging?
Not quite that fast. Once we've got a potential target, we need to do more detailed reconnaissance. Sending a probe to orbit the asteroid, taking high-resolution images, maybe even collecting samples.
So really getting to know the asteroid before we commit to a full-blown mining operation.
Exactly. We need a good understanding of its composition, its structure, its potential for extraction before we start making big plans.
That makes a lot of sense. It's a careful, deliberate process. So let's say we've found our perfect asteroid, done all our homework. How do we actually go about setting up a mining operation out there in space?
That's where things get really exciting. We're talking about deploying robotic miners, processing facilities, infrastructure for power generation, communication.
Whoa, whoa, whoa. Hold on a second. There's a lot to take in.
I know, right? We're talking about building a miniature industrial complex in space, all designed to operate autonomously with minimal human intervention. But we can delve into all that after a quick break. We'll be back in a moment to unpack how we actually make this mind-blowing vision a reality.
Stay tuned, listeners. This deep dive into asteroid mining is just getting started. Welcome back, everyone. Before the break, we were talking about building this whole industrial complex in space to mine asteroids.
And believe me, it's every bit as challenging as it sounds. We're talking about designing systems that can operate reliably in one of the harshest environments imaginable.
Right. With microgravity, radiation, extreme temperatures, it's mind-boggling.
It is. Even something as basic as power generation becomes a major hurdle. Solar energy is abundant out there, but we need to develop solar panels that can withstand the constant bombardment of radiation.
Okay, so power, that's one thing. What about getting those mined materials back to Earth? Are we talking about massive cargo ships hauling tons of ore?
Well, that's certainly one option, but it might not be the most efficient or cost-effective, especially early on.
So what's the alternative?
Remember, ISRU, in-situ resource utilization. That's where things get really interesting.
Right, the cosmic gas station concept. Using resources we extract from asteroids to create fuel and other supplies right there in space.
Exactly. Instead of hauling raw materials back to Earth, we process them on site, create rocket fuel, building materials for space habitats, even things like water and oxygen for life support.
So it's like building a self-sustaining ecosystem in space, using the resources of asteroids to fuel further exploration and development. That's amazing.
But let's shift gears for a minute and talk about what this all means for us back on Earth, the economic implications. We've touched on the potential, but how could asteroid mining really impact our lives?
Oh, the economic implications are enormous. Just imagine a future where we have access to a near limitless supply of precious metals, rare earth elements, all those valuable resources.
It's almost like the gold rush of the 21st century, but on a cosmic scale.
It is. This could revolutionize entire industries, everything from electronics to manufacturing to energy. We could see a surge in innovation and economic growth.
Wow, it's hard to even wrap your head around the possibilities. But let's get specific. What are some examples of how asteroid mining could actually impact our everyday lives? Okay, well, let's take platinum group metals, for instance. These are essential for tons of technologies, everything from catalytic converters in cars to fuel cells.
Right, and they're super expensive because they're so rare.
Exactly. Now imagine asteroid mining provides a steady and abundant supply of these metals. The cost plummets, making all sorts of technologies more affordable and accessible.
So things like clean energy technologies could become much more widespread.
Exactly. That's just one example. There are countless others. But it's important to remember that with any new frontier, there are also risks and challenges to consider.
Right, we can't just rush into this blindly. What are some of those risks, besides the environmental concerns we mentioned earlier?
Well, the geopolitical implications are a big one. Access to these vast space resources. It has the potential to create new conflicts or exacerbate existing tensions.
Yeah, that makes sense. We've seen how competition for resources has played out on Earth. We need to be careful not to repeat those mistakes in space.
Absolutely. That's why it's so crucial to establish clear international agreements and legal frameworks to govern how we explore and utilize these space resources.
So ensuring that space remains a realm of peaceful cooperation and shared benefits, not a new battleground for earthly rivalries.
Exactly. We need to learn from the past and ensure that this incredible opportunity benefits all of humanity, not just a select few.
Well said. Now, we've talked a lot about the future, but let's focus on the present for a moment. What's happening right now that's paving the way for asteroid mining?
Well, there's a lot going on. One of the most exciting things on the horizon is NASA's Psyche mission. It's set to launch soon, and it's going to explore 16 Psyche, that M-type asteroid we talked about earlier.
Oh, wow, the one that's basically a giant chunk of metal potentially worth quadrillions of dollars.
Yeah, that's the one. It's a unique opportunity to study the interior of a planetary body without having to, dig miles underground.
So we can learn about planetary cores, how they formed, how those resources we value came to be.
Exactly. And that knowledge will be invaluable for future asteroid mining missions.
Incredible. It's like we're on the verge of unlocking some of the universe's biggest secrets while simultaneously figuring out how to tap into its riches.
It's a pretty amazing time to be alive, that's for sure. And it's not just about government agencies like NASA either. The private sector is playing a huge role in this too.
Right. We talked about companies investing in this field. What kind of advancements are they driving?
Well, they're really pushing the boundaries when it comes to things like reducing launch costs. Because as access to space becomes more affordable, that opens up all sorts of possibilities for commercial ventures.
That makes sense. Cheaper launches mean more ambitious projects become feasible.
Exactly. And they're also driving innovation in resource processing, autonomous systems, all the things we need to make asteroid mining a reality.
So it's like this incredible synergy with governments, research institutions, private companies all working together, pushing the boundaries of what's possible.
It really is. And it's moving at an astonishing pace. I mean, just look at what we've accomplished in the past few years with those sample return missions. It's mind-blowing.
I know, it feels like every day there's a new breakthrough, something that pushes us closer to this future where asteroid mining is not just a dream, but a reality.
And remember, this isn't just about extracting resources for profit. The potential benefits go way beyond that.
Absolutely. We're talking about scientific discovery, understanding our place in the universe, developing technologies that could benefit all of humanity.
It's a reminder that we're explorers at heart. We're driven to understand, to push boundaries, to use our knowledge to create a better future. And asteroid mining, I think, is a perfect embodiment of that spirit.
I couldn't agree more. But before we wrap things up completely, I want to touch on one more fascinating aspect of this whole thing: the potential for space-based manufacturing and construction.
Ah, yes. That's where things get really futuristic.
Right. We're talking about using asteroid resources to build, well, practically anything we can imagine. Habitats, research stations, maybe even entire cities in space.
It's mind-blowing, isn't it? We could create entire industries in orbit, utilizing the abundant resources of the solar system to build things that would be impossible or just incredibly expensive to build on Earth.
Okay, but before we get completely carried away with these sci-fi visions, let's break it down. What are some of the specific advantages of building things in space using asteroid materials? And we're back. We're just starting to get into this mind-blowing idea of using asteroids as building blocks for a permanent human presence in space.
It's a whole new way of thinking about space, isn't it? Not just visiting, but actually living and working there.
It is. It's like those sci-fi movies where we have massive space stations and cities among the stars.
Exactly. And asteroid mining could be the key to making that a reality.
Okay, but before we get carried away with those grand visions, let's talk specifics. What are some of the advantages of actually building things in space using asteroid materials?
Well, first and foremost, there's the sheer abundance of resources. Asteroids contain a wealth of metals, minerals, even water ice, and we can utilize all of that without having to launch everything from Earth, which is incredibly expensive.
Right. It's like using what's already out there rather than depleting our own planet's resources.
Exactly. Plus, there's the unique environment of space itself. Microgravity allows us to create materials and structures that are simply impossible to make on Earth.
So we're not just talking about building things in space. We're talking about building things that are only possible because of space.
Precisely. It opens up a whole new world of possibilities for materials, science, and engineering. But of course, it's not without its challenges.
Right. There are always hurdles to overcome.
hmm
What are some of the biggest ones facing space-based construction?
Well, one of the major ones is developing the technology for processing and manufacturing materials in space. We need equipment and processes that can operate reliably in microgravity, radiation, extreme temperatures. It's not easy.
So it's going to require some major advancements in robotics, automation, material science.
Absolutely. And then, of course, there's still the cost of transportation.
Yeah, even with all the progress in launch technology, getting things into space is still expensive.
It is. But remember that ISRU concept we talked about, using asteroid resources to create fuel and other supplies right there in space. That could drastically reduce our reliance on Earth-based launches.
It's like we can bootstrap our way to a self-sustaining space economy.
Yeah.
That's pretty incredible. But I want to shift gears for a moment and talk about the people involved in all this. We've talked a lot about technology and economics, but what about the human element? Who's going to be out there building these space stations in cities?
That's a great point. We're going to need a whole new generation of space pioneers. Skilled engineers, scientists, technicians, entrepreneurs, people who are not just technically proficient, but adaptable, resilient, and able to thrive in challenging environments.
It's like the early days of exploration on Earth, but on a cosmic scale.
Exactly. And the opportunities are out there right now. Companies and research institutions are working on this. Universities are offering specialized courses.
So there's a place for everyone who's passionate about space and pushing the boundaries of what's possible.
Absolutely. If you're interested in this field, now's the time to get involved. It's a really exciting time.
I think that's a great note to end on. This has been an amazing deep dive into the world of asteroid mining. We've gone from the basics to some truly mind-blowing concepts.
It's a field that's full of potential, but also one that demands careful consideration. We need to proceed responsibly, ensuring that these advancements benefit all of humanity.
Couldn't agree more. So to our listeners, thank you for joining us on this incredible journey. It's clear that we're on the cusp of a truly transformative era in space exploration, and asteroid mining is going to be at the forefront. Keep looking up and keep exploring.